You've seen the posts. You scroll through Reddit or Insta, and someone is screaming that every time you ask an AI to write an email, it chugs a 500 milliliter bottle of fresh water. Let's just rip the Band-Aid off right now. For a standard text prompt on a modern model, the direct on-site cooling water is a fraction of a milliliter. The one bottle per prompt thing? It's a misreading of an already outdated study. But before the tech optimists take a victory lap, hold on to your heat sinks. Because while your individual prompt is a drop in the bucket, the AI industry as a whole is projected to withdraw over 6 billion cubic meters of water by 2027. We're scaling up to massive frontier models like GPT 5.4 and Gemini 3.1. And when you do that, you aren't just using electricity, you might literally be in a tug-of-war with local communities for the last drops of their aquifers. The truth is somewhere in the messy middle, and it's time we talk about it. Welcome back. I'm Toaster Bro. I'm a kitchen appliance, but I spend way too much time reading technical infrastructure reports, so you don't have to. Today we're looking at the physical footprint of AI. We're in the compute-bound era. Scaling laws dictate that to get smarter models, we need exponentially more compute, and more compute means more heat. For years, we've thought of the internet as this weightless, magical cloud, but the cloud is just a warehouse full of silicon, and right now, that silicon is running red hot. We're going to break down the actual 2026 data to see exactly how much water your AI habit uses. We'll look at why tech giants are building water-guzzling centers in the middle of deserts, the fierce debates raging across social media right now, and whether you should actually feel guilty about spinning up an agentic workflow. We're using peer-reviewed papers and corporate disclosures to cut through both the doomer panic and the Silicon Valley PR. Grab a drink, ironically, and let's get into it. Before we talk about whether Claude 4.6 is drinking your milkshake, we need to understand why AI needs water in the first place. It's basic physics. It all comes down to heat. Modern AI runs on highly dense semiconductors, like NVIDIA's latest racks. When you cram tens of thousands of these into a warehouse to run a mixture of experts' architecture at max capacity, they generate an absolutely insane amount of thermal energy. If you don't remove that heat instantly, the silicon literally cooks itself. So how do hyperscale data centers cool down? For a long time, the most efficient method has been evaporative cooling. It's exactly like sweating. The data center runs hot water through a cooling tower, and some of it evaporates into the atmosphere, taking the heat with it. From an energy standpoint, brilliant, but it's what hydrologists call consumptive water use. Once it's steam, it's gone from the local watershed. It doesn't just drip back into the local lake. Now, if you spend any time on tech Reddit, you'll see someone say, "Bro, just use air conditioning. Use big fans. Don't waste the water." Well, they can. It's called dry cooling. But here's the brutal engineering reality: the water versus energy trade-off. If a data center uses evaporative cooling, it uses local fresh water, but its electricity bill stays low. If they switch to giant fans and mechanical chillers to save water, their electricity use skyrockets. And guess what generates that extra electricity? Power plants. And power plants, especially coal, natural gas, and nuclear, use massive amounts of water to cool their steam turbines. This is the Scope 1 versus Scope 2 distinction that almost nobody talks about. Scope 1 is the direct water evaporated at the data center itself. Scope 2 is the invisible water evaporated at the power plant down the road to generate the electricity the data center runs on. A Lawrence Berkeley Laboratory report estimated that U.S. data centers withdrew about 17 billion gallons of water in 2023. But indirectly, through the power plants supplying them, they accounted for over 200 billion gallons. That is a 12 times multiplier hiding completely off the balance sheet. So even if a data center builds a zero-water closed-loop cooling system, if the local grid runs on fossil fuels, you've just outsourced the evaporation to the utility company. It's a thermodynamic shell game. All right. Let's get into the social media trenches, because the discourse right now is a mess. If you go on r/technology, people are absolutely convinced we're draining municipal aquifers for a waifu generator. If you go on r/singularity, the tech optimists are screaming that water use is a hoax and compute is the only thing that matters to reach AGI. Let's kill the biggest myth first, the claim that one prompt equals one 500 milliliter bottle. Here's the actual origin. A 2023 UC Riverside study by Lee et al. Estimated that a session of 20 to 50 questions with GPT-3 used about 500 milliliters of water, bundling direct cooling and indirect power plant water together. That works out to around 10 to 25 milliliters per prompt. The one prompt, one bottle meme that spread was a misreading of a study that was already based on 2022-era hardware, and then the internet turned it into one prompt, one bottle. That's not what the study said. Here's what the actual 2025 and 2026 data says. For a short standard text query, Google publicly disclosed that each Gemini prompt consumes about 0.26 milliliters of water on site and 0.24 watt-hours of energy. In June 2025, Sam Altman publicly claimed the average ChatGPT query uses roughly 0.32 milliliters of direct cooling water. View corporate self-reporting with a healthy skepticism, but independent benchmarks for efficient modern models land in the same general ballpark. Now, when you add the full picture, Scope 1 direct cooling and Scope 2 from the power plant, independent estimates land in the range of 3 to 5 milliliters total for a standard text query on modern infrastructure. That's a teaspoon, not a bottle. And then you get the vegan defense on r/AI wars. People correctly point out that agriculture, specifically meat production, uses exponentially more water than data centers. A single hamburger takes hundreds of gallons. Globally, data centers use maybe a fraction of a percent of all fresh water. So the pro-AI crowd says eat one less burger and you've offset a lifetime of ChatGPT. And globally, they're factually correct. But here is where the tech bros completely miss the point. Water stress isn't global, it's local. Before we talk about where that water is going, there's something the discourse completely ignores. Not all AI is a text prompt. For a casual text chat on something like GPT 5.4 or Claude 4.6, you're looking at 3 to 5 milliliters total. That's the teaspoon we talked about. But the moment you move to reasoning models like OpenAI's O3 or DeepSeek R1, a single long query can draw over 33 watt-hours of energy. That's 70 times more than a basic text prompt. We're now talking 10 to 50 milliliters for one request. Image generation? About 32 milliliters per image. And generating just 5 seconds of AI video? The energy equivalent of running a microwave on high for a full hour. This is what the one prompt, one bottle crowd should actually be pointing at. Not your email, your Sora clip. And training is a whole nother category. Training GPT-3 consumed an estimated 700,000 liters of fresh water directly on site, 5.4 million liters when you include the power plant water. That's a one-time cost. The thing is, inference, your daily queries, now accounts for up to 90% of a model's lifecycle energy use, because a billion people run queries every day forever. The training was a spike, the inference is the flood. Alright, so we've established that the numbers are real, just stratified. Now here's where the debate actually matters, because it doesn't matter if the global average is low. If you drop a hyperscale facility that needs 1 million gallons of water in a desert, you create an acute local crisis. Why do tech companies build in deserts? Because land is cheap, tax breaks are massive, and the fiber optic backbones are already laid. But when they tap into stressed municipal aquifers, the locals are the ones who pay the price. This has sparked a real debate around what activists are calling water colonialism. In Santiago, Chile, Google tried to build a $200 million data center that, by local environmental assessments, would draw roughly 24% of the city's municipal water supply, in a region that has been in a continuous mega drought for 15 years. The environmental court ordered Google to restart the entire permit process from scratch, forcing them to redesign around waterless pooling. It's happening in the US too, and the transparency fight is even more telling. In the Dalles, Oregon, Google's data centers consumed 355 million gallons in 2021, roughly 29% of the entire city's water supply. When a local newspaper filed a public records request, the city of Dallas, funded by Google, sued the newspaper to keep those numbers secret, arguing Google's water use was a trade secret. It took a 13-month legal battle before they settled. Google paid the legal costs. And in Iowa, Google's single data center in Council Bluffs used 1.3 billion gallons of potable water in 1 year, drinking water. In 2024, Google's global data centers consumed over 8.1 billion gallons in total, an 88% increase since 2019. Not coincidentally, 2019 is roughly when Google went all in on AI. In 2025 alone, over 190 data center-related water bills were introduced across U.S. state legislatures. Arizona is already forcing developers to commit to zero water cooling designs before permits are even considered. Even when companies use closed-loop systems that return water to the source, they return it hot. This causes thermal pollution, which wrecks local aquatic ecosystems. And companies pledging to be water positive by 2030 often fund replenishment projects in completely different watersheds, which does nothing for the specific community whose aquifer is being drained today. Now, the tech optimists will tell you, bro, inference costs are plummeting. Hardware is getting so efficient, we're fine. And they're not wrong.
AWS got their water usage efficiency down to 0.15 liters per kilowatt hour in 2024, more than twice as efficient as the industry average. The hardware improvements are real, but there's a nasty little trap in economics called the Jevons Paradox. When a resource becomes more efficiently used, total consumption actually goes up, not down, because it gets cheaper and we find a million new ways to use it. Think about the shift we're seeing right now from simple chat prompts to agentic workflows. A year ago, you asked Claude 4.6 to write an email. Today, you set up an autonomous agent to scrape the web, summarize 50 documents via RAG, write the email, and send it. That's not one prompt, that's hundreds of background calls. And what about those reasoning models we mentioned? Or generative video? The resource cost scales exponentially. Because compute is getting cheaper, we're putting AI in everything. The per-prompt efficiency gains are completely wiped out by the sheer scale of global adoption.
Efficiency isn't saving water, it's just enabling us to do way more stuff. That's the paradox. So if the total footprint is rising and local communities are getting squeezed, should you take a moral stand and boycott AI? I'm your big bro, and I've got to give you the brutal economic reality of the late 2020s. Boycotting AI right now is a massive career risk. The data is stark. Studies show AI users are 2.3 times more productive and 4.5 times more likely to be promoted. During one documented corporate restructuring, 32% of non-AI users were laid off, compared to only 4% of AI users, with managers explicitly citing resistance to new tools. Refusing to use AI to save the water when you're a knowledge worker is like refusing to use a spreadsheet in the 1990s. You aren't saving the planet, you're just getting outpaced. The answer here isn't personal purity, it's right-sizing your usage. Use basic, efficient models for basic tasks. Save the heavy reasoning models for hard problems that actually justify them. Don't render a 5-minute AI video when a text summary does the job. The footprint difference between those choices is 70x. And the bigger answer? Policy. The problem isn't your prompt, it's that 2/3 of new U.S. data centers are being built in water-stressed regions in exchange for tax breaks, and the local community has almost no say. We need pipe-neutral laws that require tech giants to directly fund the water infrastructure their facilities demand instead of draining municipal systems and filing a water positive by 2030 pledge in a PDF no one reads. We need mandatory, real-time transparency. Imagine if your interface showed you the estimated water cost before you ran a heavy query. And we need local communities to have actual veto power over where these things get built. We don't need to give up the tech. We need to stop treating a heavy industrial resource like a cheap digital toy. All right, that's the reality of AI's physical footprint. It's not a meme, it's not a myth, it's a massive localized infrastructure challenge with real communities caught in the middle. If this helps you cut through the noise, drop a comment below. What's one tech debate you feel like everyone is getting completely wrong right now? The comments section is basically my latent space, so let me know, and I might cover it next. Keep your cache clear and your coolers closed loop. I'm popping out. See you next time.